All right, good morning. This is Mr. Sala, and this is Thursday, September 3rd. Today's lesson is going to be on dimensional analysis. Dimensional analysis, which is also called, some people call it the factor label method. This is an important skill that we'll use in physics because oftentimes because we use one system of measurement here in the US versus almost 99.9% of the rest of the world grows up only with the metric system. We here in the US have to convert from one unit to another to get into the metric system. And what you'll need in order to do that is something called a conversion factor. And I posted on, well, you'll have access in Classroom. There's a couple of different charts you have. This is one I always pass out to students when you just didn't get there, is the conversion factor table that has a lot of different conversions there. It's a little hard to see. I tried to rotate, did not work out. Hopefully on your Chromebooks, once you open it, you should be able to auto-rotate it. And then that's just on the back, the metric stair step there. Another clean version I found back in May is this one here that has a lot of good information. Here's your, again, your metric stair step right here. And they give you some information there. And then again, you've got some really good conversions right there. In the work that you're going to be doing for me today, here you can see that every conversion you would need would be right here. And then another thing to note as we continue to make our way through physics, there's just going to be a lot of conversions that it would be helpful if you would just know. Right? So one of them would be 1 mile. 1 mile is going to equal 1,609 meters. Right? So a potential question and an example of how we do the dimensional analysis problems is how many meters are in a marathon, right? So that's maybe not common knowledge about how much, how long a marathon is, right? Well, a marathon is 26.2 miles. So growing up in the US, we can envision maybe what 26 miles is, right? Maybe it's a trip close to 30 minutes away if you're going at the speed limit of 55 miles an hour, to give you an idea. But we have a lot of visitors from foreign countries who come to the US and run the marathons, and they're not familiar with what a mile is. So there are signs out there, they have to do the conversion to put their the mileage information into meters. All right, so how many meters are in a marathon? So we already talked about a marathon being 26.2 miles, and we're looking for how many meters. Okay, and we need a conversion factor, and we have a nice clean one, which is right here. So what we can do now, because we ultimately want to get to meters, we're going to start out with our 26.2 miles. And then we're going to use that conversion factor. So we want to put the mile below or in the denominator because ultimately we want those to cancel. So 1 mile is going to equal that 1,609 meters. Right? So going back to the question again, how many meters? And we know that this is the prefix for meters. So these miles are going to cancel. And then we're left with this basically multiplication and division problem which isn't difficult because we're just dividing by 1, so we just have to multiply the numerator. So if we get over to our handy dandy calculator, we got 26.2 times 1609 is going to give us an answer. And I'm going to write out the complete answer and then we'll talk about it. So you would have 42,155.8 meters. Right? So you answered the question, how many meters are in a marathon? Well, that is the answer. But again, we can take it a step further when we start thinking about the significant digits. You have 4 significant digits here. You have 3 here. And you remember when you're multiplying, dividing, you're ultimately going with the least number or the least precise number of significant digits. So we want to be able to convert this into those 3 significant digits. So we're going to put with the 42, and then we have to start thinking about what's here. Right? So I've got 2 of my 3. You're going to wind up rounding the 1 because there's a 5 there to a 2. And then you're just going to round it with the 2 zeros. Now you have 3 significant digits, like you had 3 in the initial problem with the conversion, and it's meters. So again, if somebody asks you how many meters are in a marathon, you could say it's 42,200 meters. Also with the metric stair steps, because this is a larger number, we can go ahead and convert that into kilometers to make it even smaller. So remember when you go from meters, here's your decimal, to kilometers, right? You would go to the left 3. So again, how most people who do not grow up in the US know is that a marathon would be 42.2 kilometers. Right? So that would be an example of using the dimensional analysis method in order to convert from one unit to another. We're going to do another example before I do an example on your problem set. So we're going to look at, okay, what if there are 2 units? So again, in the US, miles per hour are common to us, right? We know, say in a school zone, you're 20 miles per hour. If you're on the highway, legally, it's 55 to 65 miles per hour. So we want to be able to convert that to, say, meters per second. So let's just go with 60. And again, this designation here is miles per hour. Miles per hour. Don't get confused with the M for miles with the M for meter here. So if you have 60 miles, now what we're going to do is we're going to set this up with the distance over the time, and that would be an hour. Right? And then you can just work with one and then the other. So again, miles. We know that 1 mile equals 1,609 meters. Right? So now we can stop and think. We have converted to the 1 unit that we need, which would be the distance. We can cancel off the miles and we're in the meters. So we're good there. Now we want to start and look at the time. So we need to go from hour to seconds. So we've got an hour here. Okay, so we have 1 hour here, and then we go 1 hour equals what? 60 minutes. And we can cancel hours. But we're in minutes and we still need to be in seconds. So then what you do is you'd have 1 minute equals 60 seconds. And then we can cancel minutes. So now again we look at So now we've got meters over seconds. So we're exactly where we need to be. Then we can just go ahead and do the calculation. So we'd have 60 times 1609, and then we would divide that by 3600, and we would wind up with 26.8 meters. Actually, yeah, 26.8 meters per second. Right? So two little notes here. Again, when we went back to the problem, we were going 60 miles per hour. So that was all we were given, and we wanted to convert it to meters per second. So because there's technically only one significant digit here, you would then round that up to 30 meters per second to show the one significant digit. Again, at this point, I'm more concerned with you getting the answer, and as we go through the year, we'll work to getting it into the correct number of significant digits. One other note is another conversion you're going to want to maybe commit to memory is 1 hour equals 3,600 seconds. So instead of doing this extra step with the minutes, you could have looked at it as 60 miles per hour. That's miles. And then again, you had 1 mile, 1,609 meters. And then here, you would just go hour again. That would cancel, and then you would just use that conversion. There's 3,600 seconds. That way you're just saving a step. And again, if you can convert some of these conversion units throughout the year, it's just easier to deal with. So again, ultimately you wind up with this answer, which then, playing by the rules of significant digits, you would move it to 30 meters per second. So again, that's just simple. We know, we kind of can feel what 60 miles per hour is. That would be the equivalent of covering 30 meters every second. Okay, so now we're just going to go ahead and take a look at the problems. I'll do one for you there. And that, let me minimize here. And then we move over to the problem set. So again, we can go ahead and let's go ahead and do number 2. It kind of looks nasty, but it's really not. It's just large numbers. So the moon is 250,000 miles away. How many feet is it from Earth? So we've got to go 250,000 miles. And we just kind of create our little T-chart here. And you look up in your conversion, and again, a mile is going to be 5,280 feet. So again, you would put 1 mile is 5,280 feet. Okay, and again for these, I'm just really looking for you to get to the right answer, and then we'll take it a step further in the future about really getting to the most scientific answer with sig fig. So again, here you would now, this is going to be a large number, but you're going to wind up with, that's going to be 1,320,000,000 feet. Right? So again, you really want to start out with what's given, and then it's just a matter of using a conversion factor to get to where you need to go. So again, we were given miles, and we want to go to feet, so then we come up to our factors, and we look for the one that's going to be most convenient for you. Right, I'll go ahead and divvy out the questions. going to give you a few and a couple challenge ones in there, so see if you can get through, and if you have any questions, you can go ahead and email me tomorrow. Remember, quiz on Friday, so you're going to want to email me with any questions tomorrow. All right, thank you, and have a great day.